Hello, yeah, welcome back to our discussion class. So today we're going to be talking and discussing on sampling and common sampling methods. We're going to be looking at what sampling means when it comes to research and in terms of public health. Okay, so we are still on biostatistics, pages 813. So, sorry, let's dive in. So I need to check my microphone. Okay, so sorry for that break in transmission. Okay, so like I said, we're going to be discussing on sampling and common sampling methods. So let's get started immediately. What is sampling? Sampling is the process of selecting a subset called sample. We've discussed what is sample when in our unit 1 when we are talking of statistical terms. Okay. You can go back to the video to watch other terms you use in statistics, like sample is one of them. So sampling is a process of selecting a subset called sample from a larger population or larger group in order to study it and make inferences or decision about the whole population. So what this means is that most times it's often impossible or expensive to study everyone that we want to. So that's why we take samples. That's to we take a representative sample that represents the whole population or the targeted population that we have in mind instead. That's why we do sampling, because it can be impossible to study everyone and it can also be expensive. So why is sampling is important? Why sampling is important? Number one, it saves time and cost. It saves time and cost. It allows for faster data collection because now you are now taking a representative sample and not studying the whole population. Number three, it enables accurate estimates of population characteristics. Number four, is useful when population size is very large or infinite. So you can use sampling to curtail a very large population or infinite population. Okay, so this is a key characteristics or the reasons why we have to sample. Then we have common sampling method. There are two main types of sampling. Okay, we have the probability sampling and we have the non-probability sampling. What is probability sampling? Just like the name, every member of the population has a known or non-zero chance of being selected. That is, everybody has an equal chance of being selected. So this method reduces selection bias and allows statistical inference. So if you followed us through when we are studying the epidemiological studies, bias in epidemiological studies, we noted selection bias as one type of bias. So you can say you can reduce um, this type of this selection bias by simply sampling, especially probability sampling, when you give every member on your study population a chance of being selected. Okay. Then this probability sampling is also called random sampling. So let's go back to the second type of sampling, which is non-probability, just like opposite of the probability. So here, every member of the population has zero chance of selection, or where the probability of selection cannot be accurately determined. Okay, so this is actually done in a situation where randomization is not possible in order to obtain a representative sample. So bias is more of a concern with this type of sampling because everyone in every one of the sample is not given that opportunity. So let's note the major difference between probability and non-probability sample is randomization. So randomization occurs when all members of the sampling frame have an equal opportunity of being selected for the study. So probability sampling, which gives every member the chance of being selected, involves randomization. And that is the major difference between the two types of sampling. So let's look at different types of probability sampling. In probability sample, we have the simple random sampling. So in simple random sampling, every member of the population have an equal chance of being chosen or selected. Select a simple random sample. First, assign a number to each element in the sampling frame. Then pick as many numbers from the table of random numbers with that number or digits as needed for the sample size required. So this simple random is very easy, something we do in our everyday life. For example, most people that are active on social media, you see someone that say, okay, for my fans, I want to do giveaway for my fans. I'm just going to select randomly in the comment section. Just make your comments and everything. So they just choose randomly in the comments who to give the money to, or maybe any gift to. So it involves sampling randomly. You're just choosing randomly. You're not being selective of who you give the giveaway to. I hope this actually explains it in a layman's term. Then we have the second type of sampling, which is systematic sampling. Here, selection is done at regular intervals. It's just like a senior brother to random sampling, but here it involves like a system. There's a system, okay, where selection is done at a particular interval or at regular intervals from an ordered list after choosing a random start point. So, for example, when you want to conduct a systematic sampling, maybe in a 10%, if we desire a 10% systematic sampling, we will determine the position of the first element by using the random number table to randomly select a number between 1 to 10. That's, you can select from between 1 to 10, okay? So let's suppose say the number we selected is 6. Just want to show you how systematic sampling works. Let's suppose the number you selected is 6. This means that the first element to be picked will be from the 6th position in that your list, from that your ordered list. Like we said, systematic sampling involves selection at regular intervals. So we've chosen randomly the number we want to be selecting. So every number we're selecting will be from the 6th position of the sampling frame. Because we have a 10% systematic sampling, then the second number will be from the 16th position. Do you understand? 16th position. So the third one from the 26th, the fourth one from the 36th, 46th, 56th, and so on. So from every um, sixth position of the sampling frame, you're going to select that number. So that is how systematic sampling is done. It involves at a regular interval, unlike random sampling that I just do randomly, but this one involves system. Okay, so we have another types of probability sampling. We have the stratified sampling. Stratified sampling, here the population is divided into subgroups called strata in plural or stratum in singular. So based on character. So the population is divided in different subgroups based on characteristics. Example, the age, the gender, the occupation, the region, a lot of them, okay? And then samples are selected randomly from each group. That's from those subgroups you've um, divided the population, you select randomly from them. So the advantage of this is that the information about the composition of the population with respect to a number of stratifying variables can be taken into account. For example, if you want to conduct an experiment in a hospital, you can divide the hospital staff maybe among the hospital staff, okay? Can divide the hospital staff into doctors, into nurses, into cleaners, or other groups in the hospital. Then you randomly select from each group. That is, you randomly select from doctors, randomly select from nurses, randomly select from cleaners. Okay, so this stratified sampling, it involves each of the subgroups are evenly represented because you randomly selected from them. So that is for stratified sampling. Then we have another one called cluster sampling. So here the population is divided into clusters or groups. Some clusters are randomly selected and all members or a few within the cluster are studied. So the difference between this cluster and stratified is that cluster are just divided into groups. Doesn't mean it mustn't be based on characteristics, but in stratified, they must be based on characteristics. Okay, so in cluster sampling, all members or a few within the cluster are studied. In forming cluster, the study units within the cluster do not need to be similar. The study units don't need to be similar, just like in stratified, that they need to be similar. You have to differentiate them into similar characteristics. For example, randomly selecting 5 schools in Abuja. Maybe you are studying on schools, maybe secondary schools, studying about phone screen amongst students in among secondary school students in, let's say, Lagos. Okay, so if you're doing this kind of study, you can randomly select like 5 schools, then survey all the students in those schools. So you have divided the schools into different groups or into different clusters. Do you understand? So we have the last but not the least type of probability sampling called the two or multi-stage sampling. This involves sampling in 2 or more stages, just like the name implies. So it is majorly used if a sampling frame is not available, or if the population is spread out over a wide area. For example, in a study in University of Lagos, the primary sampling can be the university, the secondary unit, the department in university, the third stage can be the students or the faculties. Okay, let me take this for example. We want to make a research in Nigeria, maybe studying the malnutrition rate among under 5 children in Nigeria. So for you to carry out this kind of stamp, you have to do a multi-stage sampling because you have a very wide population involved spread out in a very wide area. So you can do like, okay, the major you can do a multi-stage sampling into the major political zones. That is the first stage. After the major political zones, you can do into different like call it local government. After the local government, you can also do another stage sampling to different communities. So it's just done stage by stage. That's the difference in this type of sampling. I hope you understand the different types of probability sampling. So let's go over to the non-probability sampling. So in non-probability sampling, which involves the where there's no zero chance of being selected. So we have examples like quota sampling. Quota sampling, here the population is segmented into different subgroups, just like in that stratified sampling, different strata. And then a non-random set of observation is chosen from each subgroup to meet a predefined quota. Do you understand? So here, you just divide the groups into subgroups, just like the stratified, but here a non-random set of observation, or like you not choose at random, just like in stratified, but here you just choose non-randomly from those subgroups. Example, interviewing 30 men and 30 women at a mall. That is whoever comes first, you just interview. It doesn't matter who comes first and who does not come. So there is no randomization is based on to meet a particular predefined quota. Okay, so that's for quota sampling. Then we have another type, judgment or purposive sampling, where participants are selected based on specific characteristics or based on researchers' judgment. Because maybe you want a particular information or you want your research to be in a particular group. That's how you select that particular study group. For example, selecting only diabetic patients for a wound healing study. You can see is a kind of purposive because they have diabetes, because they are diabetic patients. That's why you are particularly selecting them. So we have another type, convenience sampling, which can also be called accidental or opportunity sampling. Here, participants are selected because they are easily accessible or they are easily available. So this type of sampling is mostly used for pilot testing, where the goal is instrument testing or measurement validation rather than obtaining generalization inferences. For example, sharing questionnaire surveys in front of a shopping mall, or just randomly sharing, sorry, just like because these people are the you have easily access to them. That's why you actually decide to study them. Okay. So we also have expert sampling. As here, the respondents are choosing in a non-random manner based on the expertise of the phenomenon being studied. For example, you want to get knowledge on some cultural practices in a local community. You want to interview the local chiefs. It's an expert sampling because you know that the one that will give you the right information you actually need for that particular study. That's why you are meeting them. So it's an expert sampling. Then we also have another one, snowball sampling, which is majorly used for hard to reach or hidden population. So here is for most people that there are some studies that you carry out, you will not have that accessible population or group of people to study. So this kind of people you meet, maybe you just know one person that can give you information, and that one person will connect you to that another person in the study group. Just like when you're studying people living with HIV or drug users, okay? So people living with HIV maybe is a kind of a constrained group because they don't want you to know more, or they don't want people to know about them. So when you interview someone living with HIV, you can tell him or her, please connect me with another person that you know that have this disease so I can interview them, or we can also get information from them. Do you understand? They're majorly used in hard to reach or hidden population. So these are the different type of sampling, um, the probability and non-probability, and I hope you're going to be able to recall them if any of them come out in exam hall. So let's remember, check out our exam or TMA questions. Number one is what is sampling and why is sampling important? Number two, differentiate between the following: stratified and cluster sampling. Number one, probability and non-probability sampling, stratified and quota sampling, then simple and systemic sampling. Can you do that? At this point, you've learned a whole lot about sampling, and it's now time for you to give back. So let's say, for example, this is an exam question. So you can just bring out your book and try to write down on the things you can remember on each of these um, sampling techniques. Okay, so if you are watching to this extent, I want to say thank you so much for joining our class discussion for today. And please don't forget to subscribe to the channel and also share this class, share this our discussion to your friends and to those people that you know that will actually need this information. Please share it to them, to those groups you are in, to those your friends that you know that are offering these courses. Please share it to them so that they will be of no. Okay, so thank you so much for joining, and honestly, I can't wait for your feedback in the comment section so I will know what is working and what is not working. Just let me know your feedback. If you have any question, you can drop it in the comment section of this little so we can tackle it together. So I'm going to see you in the next class, and we're going to be discussing the prevalence, the incidence, and screening tests. Okay, so I'll see you in the next class. Bye.